All right, good morning. Okay, so you have two assignments due tonight. Okay, one is the radian activity, and the other one is the draw and name an angle in standard position. Now, I had a few students contact me about being confused, so I'm going to take questions and please ask during class so I can answer them all at once rather than 15 different times. All right, so what are your questions about drawing and naming an angle in standard position?
That sheet that you gave us on like the Greek letters, we can use any letter, the capital ones.
Yeah, can't use the capital ones. So the capital ones like sigma, that represents a sum of numbers. So those capital ones, some of them mean sets of numbers. So you don't want to use the capital ones. You have to use the lowercase letters. Okay, so if you're going to name an angle, you must use a lowercase Greek letter, not an uppercase one. So thanks for bringing that up.
Okay, thank you.
Mm-hmm. All right, does anybody want me to work a problem just to make sure that you are showing your work correctly?
Oh yeah, can you do number 7?
-3π/8, right? Radians. All right, so the first step was to draw the coordinate plane and make sure you label it. And sometimes you'll see people draw a circle. We're not talking about the unit circle right now, but pretty soon you'll see I'll draw a circle also. Anyhow, this is a negative angle, so it's going clockwise. So that means you're going to divide the bottom into 8 equal parts. If it's an improper fraction, you would have to not only divide the bottom into 8 equal parts, you'd have to divide the top into 8 equal parts. So the axis is actually going to help me out here. So what I'm going to do is I'm going to draw 4 sectors here and 4 there. And I'm going to try to make them look as equal as possible. So there's 1, 2, 3, 4. And over here, I'm going to do the same thing. 1, 2, 3, 4. So there's 8 pieces of pie. So your initial side lies on the positive x-axis. And make sure you draw it as a ray and not a line segment. So now you always start from the x-axis. So this angle right here would be -π/8. This angle would be -2π/8, which is really not over 2π/8 at all. It's -π/4 because we're going to simplify. So this angle right here is going to be -3π/8, and that's the one we want. So you would draw the terminal side. So, right, -π/8, -2π/8, -3π/8. So this would represent the angle. So you show the arrow. You label the angle alpha near the arrow, and then you state the quadrant. So remember the steps. You're going to draw the coordinate plane. You're going to draw the appropriate fractional parts. You're going to draw the angle in standard position. You're going to use the arrow to show the rotation, and you're going to name the angle. And the last thing is the quadrant. So what quadrant is this in?
4.
Okay, so what were you getting confused about?
I just wanted to check to make sure that I was doing it correctly.
Oh, okay.
And you want us to simplify it too, like you did with that one if it was -2/8π?
Well, in this particular problem, we're not concerned about that angle. So I'm going to think of it as negative 2 pi over 8. But if I was concerned about the angle, you always simplify. So we're never going to leave something like 16 pi over 18. We're never going to leave that. We're never going to leave an angle like 6 pi over 12. So if we're interested in that actual angle, we'll always simplify. But I'm not interested in that. I'm not interested in that angle. So that's why you heard me say negative pi over 8, negative 2 pi over 8, negative 3 pi over 8. Other questions? Well, you realize that if it has an odd denominator, like 3, 5, 7, 11, that sometimes you might want to erase the axis because it's not helping out in making equal parts. I left it here because since the denominator was 8, I knew I was going to draw 4 over here and 4 over there. All right. Anybody else want me to work a problem?
Can you do number 12, please?
Number 12?
Yeah.
Okay. Didn't I work this problem yesterday in class?
Oh yeah, you did. Sorry.
Yeah, I graphed positive 315. So we'll do negative 315. So a negative angle is clockwise rotation. So we're going to divide the bottom into parts. So this 90 degree would be negative 90 degrees. This would be negative 180 because we're rotating clockwise. So 90 more would be negative 270 and a full revolution would be negative 360. So the angle is somewhere up here because you're rotating like this, right? So 315, you can either put 45 degrees here, or you could divide it into 30, 60, 90. So I'm going to see how this works. I'm going to divide it into 30-degree angles, and I'm just going to write that in there. 30 degrees, 30 degrees, 30 degrees. That adds up to 90, right? So what's negative 270 minus 30?
Negative 300.
Negative
So
300.
that's not it. And then so what's negative 270 and 30? So see how it's not working out exactly right, but I could still take half of 30 and I could split that down to 15 and 15. If I wanted to. But as I'm doing this, I'm thinking, oh, you know what? I think what's going to turn out to be better is if I just make it a 45 degree angles. Because if those are 45 degree angles, it would be negative 270 minus 45, which would be negative 315 degrees. So that's going to work. I'm going to put my initial side on the positive x-axis. I'm going to swing the arrow all the way over here, and I'm going to draw my terminal side. And I'm going to name my angle. This time I'm naming it beta. So what quadrant is this angle in?
1.
Quadrant 1.
So you have to stay aware of, is the angle positive or negative? If the angle's positive, you have to rotate counterclockwise. If the angle's negative, you have to rotate counterclockwise. So positive is counterclockwise, negative angles are clockwise. Other questions? Please ask me now. So the worst thing that could happen is after class, 20 people message me, can you help me? Can you help me? No, I'm going to help you now. All right. So if you have questions, ask me now. All right. So nobody wants any other problems worked. Everybody understands how to do the fractional parts and how to get the angles. All right. All right. I'm going to teach lesson 17.1. This is part 3. I don't know how many parts are going to be. I still have quite a few pages left to teach. So, but I do want to make an announcement. On Monday, you are not going to report to WebEx. Okay, I have to go to a meeting. So what you're going to be doing is, and I will let you know, you're going to be working in your Math Wizard teams. And you're probably going to be working on the practice AB of 17.1 and the online work for 17.1. So you're going to have plenty to do. So the timing's kind of good because you're not going to really need me anyway. So, but on Monday, I'll be sending out messages. I'll be sending out probably an email about it. But no WebEx meeting on Monday. You'll be working in your Math Wizard teams on practice AB and or the online for lesson 17.1. Questions? All right. Well, yesterday we talked mostly about drawing and naming an angle in standard position. So now I want to go into something called coterminal angles. This is still lesson 17.1. So coterminal angles are angles they're angles that have the same initial and terminal sides. So I'm going to draw two angles. First angle looks like this. And I'm going to call it alpha. And the other angle looks like this. Beta. So alpha is a positive angle and beta is a negative angle, but these are coterminal. So the reason why they're coterminal is they have the same initial and terminal sides. Now I'm going to draw another one in a different color. So check this out. So let's call this angle theta. This is coterminal also. Why? Because it has the same initial and terminal sides. And there's infinite ones. So I can just keep going on and on and on. And I can just keep rotating and rotating and rotating. So there's infinite coterminal angles. Now, If I ask you to give me coterminal angles, we don't want to have to graph all the time. Graphing is tedious. So I'm going to give you a hint about coterminal angles. Coterminal angles add or subtract. (360) or 2 pi radians should be coterminal angles like with a dash. You're going to add or subtract 360 or 2 pi radians to get coterminal angles. So this is how we're going to do it mathematically, is if we want coterminal angles, you could just add or subtract 360. Or if you're working in radians, you could add or subtract 2 pi. So in your lesson 17.1, these are going to be the directions. It's going to say find each angle.
Can I put your camera a little bit, please? Or actually, never mind. I can see it.
It's actually for each angle. Okay, for each angle, find the nearest two positive coterminal angles and the nearest two negative. Coterminal angles. So they want us to find two positive coterminal angles, and they want us to find two negative ones nearest to this. And we do not want to have to draw a graph. So you tell me, how can we get two positive ones? What would be the two positive coterminal angles? What would you do?
Would you add 360?
Sure. So you would take 23 degrees and add 360. So you would get what, 383? So that's one that's close. How would you find the other one? Couldn't you just double 360? So isn't doubling 360 720? So what would that be? 743? So those would be the nearest positive coterminal angles. How would you find the negative ones?
Subtracting 360.
Subtract 360. So what would that be? Let's do it on a calculator. What's 360 minus 23?
Be 37.
Now, one thing, did you guys notice that I'm putting the degree symbol on everything? Because if you don't put the degree symbol, what does that mean?
It's just a number.
No. It means radians. Remember, if you don't put a symbol, it means radians. So look up here. Instead of 383 degrees, you mean 383 of these, which is totally different. 383 degrees is a little over a revolution. 383 of these is a lot of revolutions. All right, how do you get the other negative coterminal angle that's nearest to 23?
Could you subtract 720 degrees?
Right, so what would you get?
697.
Degrees, right? So that's about it. Not too hard. If you're trying to find coterminal angles, you're either going to add 360 or a multiple of it. For positive ones, for negative ones, you would subtract 360 or subtract a multiple of 360. So let's look at one of these in radians. Negative 1/9 of pi. We want to find two positive coterminal angles that are nearest that and two negative coterminal angles that are nearest that. So what would you do?
For the positive one, could you add 2 pi?
Now, when you add 2 pi, you're going to need a common denominator, right? So this is a little more tricky than degrees, but listen, you guys, this entire class of pre-calculus is going to be nothing but fractions. So that's why I told you that you got to be really comfortable with adding, subtracting, multiplying, and dividing fractions, because the entire class is going to be this every day. So this is going to be negative pi over 9, and this would be what, plus 18 pi over 9? So what's 18 minus 1? (17 pi over 9 radians? Yes?
Yeah.
So how would you find another one?
Plus 4 pi?
And then once again, got to get a common denominator. So you multiply by 9 over 9. And by the way, this second step, eventually you'll skip it. Pay attention to it, please. So as we do this at the beginning, you'll be writing this step, but then you'll skip it, because you'll look at this and go 36 minus 1. You get me what I'm saying? 36 minus 1. I won't skip it though for now. Wrong color. So this is going to be negative pi over 9 plus 36 pi over 9 would be what?
35 pi over 9.
And by the way, if you can simplify, you do want to simplify. How about two negative ones? What would you do with negative pi over 9?
Subtract 2 pi.
Subtract 2 pi. You need a common denominator. So we'll skip the second step. What's negative 18 and negative 1?
Negative 19.
And how would you find another one that's nearest?
Four pi.
So wouldn't this be a negative 36 and negative 1 would be negative 37? pi over 9 radians. You guys okay?
Yeah, I'm following along so far.
Is everybody okay, or do you need another example?
I could use another example.
Now, if you want to check this, you could graph them, and you would see that these coterminal angles have the same initial and terminal sides. But thank goodness we don't have to graph this. That would be a big waste of time. Two-thirds of pi radians. If we want to find two positive coterminal angles, what would you do?
Add 2 pi.
So if you add 2 pi, you need a common denominator. What are you going to multiply by?
2 over 3.
So what would this be?
2 pi over 3 plus 6 pi over 3.
So what's 2 pi plus 6 pi?
5 pi over 3.
2 pi
8
plus
pi
6
over
pi?
3.
8 pi over, yeah, 3, sorry.
So how would you find another positive coterminal angle?
Add 4 pi.
So how would you get the common denominator? Multiply by what?
2 over 3.
So isn't this 2 pi plus 12 pi?
Which would equal 14 pi over 3.
And like I said, if you don't want to skip that second step, don't. Two negative coterminal angles. You would take 2 pi over 3 and do what?
Subtract 2 pi.
Subtract 2 pi, get a common denominator. So wouldn't this be 2 pi minus 6 pi? So what's 2 pi minus 6 pi?
Negative 4 pi over 3.
And we need one more. So we would subtract 4 pi. What's the common denominator?
3 over 3.
3. So this would be 2 pi minus 12 pi. What's 2 pi minus 12 pi?
Negative 10 pi over 3.
Now, I just want to give you a word of warning here. It's not always quite this easy. Let me just show you something real quick.
Is that 2 pi over, or is that 2 pi?
29 pi over 2.
Okay, 29 pi.
Now, a minute ago, you told me to add 2 pi. Well, what happens if I subtract 2 pi? Isn't that going to be 29 minus 4, which is 25 pi over 2?
Just still a positive.
And it's still positive. Do you follow me?
Yes.
So if they're asking for the nearest ones, if you add 2 pi and add 4 pi, you didn't answer the question correctly. Because you didn't get the nearest ones. So the nearest ones would be subtracting 2 pi and adding 2 pi. Those would be the nearest coterminal angles. Do you follow me?
Does it have anything to do with the 29 being larger than the 2 on the bottom?
It has to do with this being bigger than 2 pi. That's what it has to do with. Because 2 times what is 29? 14. 14 and more, and a little bit more. So it has to do with that number and being bigger than 2 pi. So just be cautious that the key word is they want the nearest coterminal angles. And if you add 2 pi, you're going to get one of them. But if you add 4 pi, that's not as good as subtracting 2 pi. Subtracting 2 pi would give you one nearer.
How would you do those for negative when you're looking for 2 negative angles?
Same thing. If you notice that, you know, you could get in one that's nearer, then you have to get one that's nearer. So let's just take one in degrees. Like, well, they want 2 positive coterminal angles. Well, adding 360 is not going to give you a positive. Adding 720 is not going to give you a positive. Right?
Right.
So you'd have to triple it. So you'd have to triple 360. So what's 360 tripled?
One 1080.
What is it?
1080.
So what's 1080 minus 756?
324.
So there's one positive coterminal angle. What would be another one? You'd have to add another 360 to this, right? Yes.
Yes.
So do you guys get what I'm saying?
We just would keep quadrupling it or like doubling it or so on.
Just remember, it has to be multiples of 360. So it could be doubling it, tripling, quadrupling it, you know, whatever you need to get what you need, get what they're asking for. It's just multiples of 360 or 2 pi. So you could use 2 pi, 4 pi, 6 pi, 8 pi. Okay? All right. You guys ready to start the lesson now? So now we're going to start the lesson. We're going to do the first objective in 17.1. All right, so the first objective in 17.1 is converting between,
Could you just board up a little, please?
yeah, degree measure and radian measure. So those are the two ways to measure an angle, is radian and degrees. Now listen carefully. I mentioned this before, but I'll mention it again. When you're working in radians, work with radians. When you're working in degrees, work in degrees. So why is the first objective converting? Because there's some formulas that only use degrees. And so you would have to convert radians to degrees, otherwise you can't use the formula. So it's mostly for formula use. You might have to convert. All right, this is really easy though. So we're not even gonna remember, we're just gonna use common sense, but I'll write this up here. So degrees to radians, you're gonna use this, pi radians over 180 degrees. From radians to degrees, we're going to use 180. So sometimes I don't even write this on the board because I don't want you to memorize it. You're going to use common sense. So here's your first problem in the lesson. It's going to say convert from degrees to radians or radians to degrees. All right. 20 degrees. Well, let's just think about this. Let's use common sense. If we're going to convert from degrees to radians, don't we want to get rid of degrees? So if you want to get rid of degrees, wouldn't you put the 180 degrees on the bottom so the little degrees cancel? So what's equivalent? Do you guys realize this is 1, right? So pi over 180 is 1, just like 5 over 5 is 1. So these conversion rules are equal to 1. So what's equal to 180 degrees? What's equal to 180 degrees in radians?
Pi.
So here we go. 20 goes into 18 how many times? 9?
Yes.
Negative 60 degrees. We want to get rid of degrees, so put degrees on the bottom. So what's equivalent to 180 that you're going to put on the top to create a 1?
Pi radians.
Right. So we cancel the little degrees. We still have a negative. 60 times what is 180? You're going to cross cancel, right?
3.
So wouldn't that be negative pi over 3 radians? What about 315 degrees? Well, 315 degrees times, we're going to put a 180 degrees on the bottom. What's equivalent to that is pi radians. So we cancel little degrees. This time it doesn't go in evenly, but the top and the bottom is divisible by 5. So 5 times what is 180? It's actually divisible by a bigger number than that. What goes into 315 and 180? And you don't have to sit around and think about it forever. We can divide by 5 and then take a look at it again. Does anybody have a better number?
Does 15 go into both of them?
Maybe. What's 315 divided by 15?
It's 21.
What's 180 divided by 15?
It's 12.
So now we see what they're both divisible by 3. So 3 times what is 21, 7. 3 times what is 12, 4. So our real answer is 7 pi over 4 radians. You guys see that okay?
Yeah.
Let me come over here. Negative 540 degrees. To convert to radians, we put 180 degrees on the bottom, pi radians on the top, cancel the little degrees. We can cancel the trailing zeros. And then 9 times what is 18.2? 9 times what is that? 6. And we can cancel again and make that a 3. So wouldn't this be negative 3 pi radians?
Could you shift your camera a little bit, please?
So I divided by 9, and then I could divide by 2. Let's do one more, 600 degrees. So 600 degrees, on the bottom you'd have 180 degrees, on the top you'd have pi radians. So we cancel the little degrees, we cancel the trailing zeros. 6 times what is 18.3? 6 times what is that? 10. So wouldn't this be 10 pi over 3 radians? Okay, you ready to go the other way now? So this is all degrees to radians. So how do you convert from radians to degrees? Now, remember a long time ago, I told you it's very important that you know how to cross cancel. Do you guys realize how many times I'm cross canceling right now? And do you realize what a nightmare it would be if you can't cross cancel? Help me keep track of time here. I only have, what, 2 minutes, right?
Yeah, like 3.
Yeah.
All right. So now you have pi over 8 radians. So how would you convert? Well, you have to get rid of radians. So when you put pi radians on the bottom, and what's that equivalent to? 180 degrees, right? So now can't you cancel the radians and pi? And 2 goes into 8 4 times. 2 times what is that? 90. So what's 90 divided by 4?
22.5.
Degrees. So what about 4 pi over 3 radians? When you put the pi radians on the bottom and put 180 degrees on the top? So you can cancel the word radian, you can cancel pi. 3 times what is 3? 1/3 would be what, 60? So what would this be? $240 degrees? 60 times 4? Yes?
Yeah.
All right, well, I still have 5 pages to teach. But that's it for today. If you want to do the first problems in the assignment in your book, I'm not posting the assignment right now. So, but if you want to do the first problems that we've covered, the coterminal angles and converting, go ahead and do that. All right, and I'm hoping I can finish the lesson tomorrow in part 4. All right, okay, you guys have a good day. I'll see you tomorrow.
Bye, Miss Birch. Have a good day.
Bye, guys. Bye, Daniela.